holding something in your hands. Stick around as we begin with the last 24 hours at our star at spaceweathernews.com. We find that small popping activity at the northern wannabe active region continues. Coronal hole will deliver intensified solar wind within 48 hours, and any small CMEs from the north will likely run up the trailing edge of it. We also had a bit of solar flare activity at the southern active region. High C class was the peak, nearly M class, and the active region it came from is such a thing to behold. Lead umbra is bigger than Earth, complex magnetism throughout the spreading region and into the trailing umbra. It may not be done flaring yet. Let's go next to magnetars, but for a completely different reason than normal. The only FRB ever discovered coming from our own Milky Way galaxy, they are pretty sure came from a magnetar. This is different than its L-shell field snap we're used to seeing. This emission occurs at the polar region. Again, very different phenomena than literally every other magnetar flash and eruption, and while it doesn't help them explain the patterns in FRBs, or the plasma lens item we saw yesterday, it does tell them that, at very least, some form of those FRB emissions can come from magnetars. By the way, it wasn't until the shock material created X-rays in their collisions with surrounding fields of material that Chandra was able to fill in the missing pieces. Anyway, back in August we examined the plasma halo discovered around Andromeda. So vast and enormous, it touches that of the Milky Way. Not only are the vast fields of plasma watching dark matter get the credit for their gravitation and electromagnetic action, but now the rest of the story is being written. In the plasma cosmology, we need not only those enormous plasma halos, but if they are close enough and interacting, there needs to be a filament between them, a hot bridge of gas. Amazing. It didn't take but a few short months, and we now know that the plasma cosmology version of circumgalactic medium and intracluster interactions works at very least with our closest neighbor. Folks, our top story today is a confirmation of multiple items regarding the sun's superflare. A paper came out a few weeks ago suggesting that the sun's maximum capacity flare was around the Carrington event power, the storm of 1859, the largest in modern times and coincidentally in the same year as the magnetic shift began. The idea that the sun can't go bigger is not supported by physical evidence. In fact, in the premium astrophysics textbook on solar storms, and in Chapter 8 of our book, which reviews extreme solar activity, the sun's maximum is tremendously higher. That's why it's a nice confirmation to see some of the top researchers in this field come up with the better answer here, and they put some whipped cream on top. You can see their main conclusions well summarized at the bottom of the paragraph: an X700 flare every 3,000 years, and X1000 flare every 6,000 years. Appropriate cycles. The same power suggested in both those textbooks I just showed. But more than the confirmation of the sun's power is that cycle timing, especially since it fits the other cycles we know about. Yesterday's introduction was on the very long cycle, but we know the Carrington event at around X40 is actually a 200 years or so event. Something stronger is likely happening on a millennial scale, and this all helps the stories of Drs. Peratt and Schock, as well as Randall Carlson and his newfound focus on the solar trigger. So folks, as we were creating the book item for 1111, a glitch took its hidden status off, and 10 of you happened to swoop in and pre-order it. Our mistake. But since it happened, I'll make you a deal. The book will be released fully for pre-order tonight if we get 7,000 likes on this video. It's the only thing that beats the censorship algorithms, and we greatly appreciate your support. We've got wind maps and shots of our star to close, and of course we'll do this all again tomorrow, right here, but right now at 5:15 a.m. in the new Valley of the Sun.